Welcome to the Koraman Academy course on Quantum Computing Prerequisites. Quantum computing is a new field that promises vastly greater computing power. Now, when you hear greater computing power, you might be thinking, so what? My laptop is fast enough. But there are problems that are so complex they cannot be solved by the fastest digital computers we have today. Medical researchers have long wanted to understand the molecular behavior of cells in our body. Cells are like machines. The proteins within cells are like the gears and components that make the machine work. The behavior of proteins is related to the shape of the protein molecule. But unlike the simple molecules we study in high school, the shape of a protein molecule is not easy to compute. A protein molecule is like a huge tapestry that folds into a complicated shape. This complicated shape is essential to how the internals of a cell work. Here is an illustration of the complexity of protein shapes. If we can compute the shape of a protein molecule from its structure, it is expected that we will be able to design better treatments for infections, cure certain types of cancer, and reverse some of the effects of aging. It is believed that quantum computers will be able to solve such problems in biochemistry. Unlike traditional computing, which is built on intuitive logic and step-by-step algorithms, quantum computing is based on mathematical models of quantum physics. To understand quantum computing, you need to become familiar with the weird behavior of quantum systems and how the physics of the quantum world is represented in math. Fortunately, though quantum physics requires a strong foundation in math, you only need to know relatively basic math for quantum computing. This course helps you build a strong foundation in basic math. We will be discussing Boolean logic, logic circuits, cryptography, probability and statistics, complex numbers, and linear algebra. For quantum computing, you need crossover skills. You will need to use probability combined with Boolean logic. Similarly, you will need to know how to use matrix algebra in combination with complex numbers. This course gives you the necessary crossover skills. We focus only on what you need for quantum computing. You don't waste time learning unnecessary material. This fast-paced course will help you learn the basics of math for quantum computing in less than 4 hours. This course also has prerequisites. This course assumes that you have already completed high school through 12th grade and that you elected to take math and physics during the final 2 years of high school. Though this course covers linear algebra, probability theory, and complex numbers, it is primarily a refresher course. It builds upon the foundation you obtained from studying these topics in 12th grade high school. Finally, this course is meant for students who enjoy math. If you were in the habit of reading your math lessons before your high school teacher discussed them in class, then you will enjoy this course. All the lessons in this course have hand-synchronized closed captions. If you don't already have closed captions turned on, then turn on closed captions now. The captions are accurate and precisely synchronized with the audio. Turning on captions will make it easier for you to understand this course.